We're going to continue on learning about graphing, and we're going to be working with slope in this lesson. So the slope is a ratio of the vertical change, which we call rise, to the horizontal change, which we call run. So a lot of times you hear the phrase slope is rise over run, and this is where that comes from. So first let's explore finding the slope of a line given 2 points on the line. When we're given 2 points, we take the two y coordinates and we subtract them. We take the two x coordinates and we subtract them. A lot of times students say, how do I know which one is y1 or y2? The first point in the problem is y1, x1, or x1, y1. The second point in the problem is x2, y2. So that's just the general way. You don't have to label them that way, but that's the easiest way for me to give you something that's consistent that will work every time. So if I have these 2 points, -6, 9, and 3, -5, I'm going to label my x and my y's together so that I'm clear. This is a great habit when you're showing your work to do it in this manner. Then you're going to take the two y coordinates and subtract them. So -5 minus 9, 3 minus -6. If you struggle with negative values, you can use the Web 2.0 calculator and type in -9 minus 5. That's okay. It might take a little bit longer, but I really want you to get the right answer. So we get -14 over 9, which means that the line is going to go down 14 and to the right 9 on each one. Now, how are we going to find the slope if we're given an equation? So this would be a different type of problem. So let's say we're given an equation like this one, 3x minus 4y equals 12, which we learned previously, that's called standard or general form. If I want to do that, I can find the intercepts of this equation and use those 2 points in the slope formula. So if I plug in 0 for x, I get -3 for y. If I plug in 0 for y, I get 4 for x, and that's where these 2 points come from. Then I'm going to plug those into the slope equation to get 3/4. So when you're given an equation in standard form, you can find the x and the y-intercepts, which gives you 2 points, so you can use the slope formula. Now let's try this. Find the slope of each line. Y equals -3 is going to be the horizontal line. Now, any horizontal line is going to have the same slope. It's going to always be a slope of 0 for any horizontal line. And that's because anything you get at the top is going to be subtracted to become 0. So that's just a great thing to memorize or to put on a note sheet. Y equals a number, boom, the slope is 0. So keep that straight. Now, if your x equals a number, the slope is going to be a little different because the denominator is going to be 0 every single time, which we call undefined. So a lot of times students want to say that the slope is 0 when there's a 0 in the bottom, and that's not true. The slope is actually undefined in that case. So this just reiterates, if I have a horizontal line, y equals a number, the slope is 0. If I have a vertical line, x equals a number, it's going to be undefined. Now, here's another example of finding a slope of an equation. So we're going to solve the equation for y. This is a different method than the intercepts. If you like the intercept method, keep going with it. If you don't like the intercept method, here's an alternative. You can solve this equation for y by subtracting 3x from both sides and then dividing by 4 to give you the equation -3/4 x plus 9/4. When an equation is solved for y, the slope is always the number in front of x. So that would make the slope -3/4. If you feel more confident with this method, then continue with this method. Now let's graph a line given the slope and a point on the line. So if I have the point -3, -2, and I know my line has a slope of 1/2, then I am going to go ahead and plot that point of -3, -2. That's the first step. Then I'm going to use rise over run. This is going to rise 1 and run 2. So up 1 to the right 2. I'm going to move up 1 over 2, there's my new point, and I'm going to connect the dots. And so when you're in the lab and you're graphing this, you're going to choose the line tool. You're going to put your dot here, up 1, over 2, and click. And that's going to complete the line for you. Now we can talk about some general rules with the slope of a line. If the line is inclined from the left to the right going up, the slope is going to be positive. If the line is inclined down from the left to the right, the slope is going to be negative. If it's a horizontal line, the slope is going to be a 0. And if it's a vertical line, it's going to be an undefined slope. So let's use the slopes to determine whether two lines are parallel, perpendicular, or neither. In order to do this, you must know the slope of both lines. The parallel lines are going to have the exact same slope, and the perpendicular lines are going to have a different case. So if I want to find a line that's parallel to another one, I just need to find the slope. If I want to find a line that is perpendicular, I have to do an extra step, which we're going to see in a minute. So if I want to know if these two lines are parallel, what they're asking me is, do they have the same slope? So I'm going to use the slope formula to find the slope of my first line. Then I'm going to use the slope formula to find the slope of my second line. So I get 3/4 for both slopes, which tells us because it's the same slope, it's going to be parallel lines. Now, perpendicular lines are something they're going to say that's the negative reciprocal. A better way to remember this is to change the sign of the slopes. If it's positive, it becomes negative. If it's negative, it becomes positive. And then to flip the number. So if I'm asked if these two are perpendicular, first I'm going to find the slope of each line. Let's do it by solving for y. So I will solve each equation for y, and I look at the two slopes. I have -3/5. The opposite sign is positive, so far we're good. If I flip 3/5, I get 5/3, so then we have the slopes there. So these two lines are going to be perpendicular. Now let's look at this one. Are they parallel, perpendicular, or neither? And the way you know they're neither is if the slopes are not the same and they're not the negative reciprocal or the opposite. So we're going to find the slope of each line by solving for y. And I get 4x minus 2 with a slope of 4 and 1/4 x plus 2, which is a slope of 1/4. This is actually going to be neither because I don't have opposite signs, so they're not perpendicular, and 4 is not equal or congruent to 1/4. So let's look at problems that are going to involve the average rate of change. The slope formula applied to any 2 points is called the average rate of change. So it's a new way we can ask you to find the slope. In a problem, they would say something like, how does it compare to the average rate of change found in example 9? So I would follow the slope formula once I see that keyword and I get a slope of 1. So I know that means 1 million customers per year. And if I compare this to the slope in example 9, it's less than the average rate of change from 2007 to 2012. So I know that it's decreasing, or it's increasing but slower. So it's a slower increase there than the other one. Here's another example. It says find the average rate of change, and you have to look at, we have 2,941. That's the point, 2,943. Then we have in 2011, we sold 241 million. So then I have 2 points. Once you've gotten the 2 points extracted from the word problem, you can just find the actual slope. And that gives us -63.8, which means we're decreasing the rate sold by about 64 million per year.